Welcome to 2.3 or 2.2, and this is about quantitative. I don't want to admit this, but this is my second video because I forgot to hit record on the first one. So it lets you know, yeah. Hopefully I'll remember to say everything I like I wanted to in the first one. So let me close this and reopen it because I had a lot of already written on here. All right. We need to talk about how we organize our quantitative data. Again, remember, quantitative data has three types of charts. We talked about qualitative having what? A bar graph, a Pareto chart, and a pie chart. Quantitative has the histogram. I can't stress enough what is the difference between a bar graph and a histogram. They look very much the same. The difference is the bars don't touch with a bar graph. With a histogram, they do touch. So with discrete, this is discrete. Remember what discrete was? No fractions. So I bet your guys sitting here screaming at me saying, do you mind sharing? There we go. I am sorry about that. Glad I hadn't started anything really yet. But yeah, we're gonna start with this, and we're gonna start talking about classes. And the classes really are categories or the variables, except with quantitative and continuous, a lot of times we have class widths because of the fractional versus the discrete, which is 1, 2, 3, 4. With class widths, we have to have the continuous to allow for all the fractionals. Can you imagine how many little tick marks across the bottom if we had to include every fractional? No, it'd be insane, drawing all those different bars. But with discrete, sometimes we don't do that. We leave each class itself because in this case, how many bars would I have? Well, 0 to 7. That's not bad. So the first thing we have to do is create a histogram. Not histogram, a frequency table. Told you this what happens. Well, I already have it. Because remember, the 0, 1, 2, forgot I have to arrow down. And our biggest number of siblings is 7. Now I'm going to have to move this again. Okay, this is what I'm doing. I'm doing the frequency table for these. It's 0 to 7. And we could go through, how many zeros do we have? We have 1. Small table. How many ones? 1, 2, 3, 4. 2s, 3, 4, 5, 6, 7, 8. Last time we did tally marks. Well, this is slightly smaller. So this has a 3. This 4s have 2, 1, 0, 1. I already had tallied, but all I did was I went through and I counted. And then double check. I'm going to add the frequencies up, and I'm also going to count. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This should total to 20. So 1 plus 4 is 5, plus 8 is 13, 16, 18, 19, 20. So I have no mistakes. All right. But we want a frequency and a relative frequency. So remember how we did the relative frequency. Well, relative frequency, we take 1 divided by the grand total and then get the decimal. Well, these are all going to be even. So normally I say take it to 3 decimals. I'm going to take it to 2. So 4 divided by 20, that is 0.2. 8 divided by 20, Three divided by 20, no, 0.10, sorry. Now, something I didn't mention in 2.1 is that we really should total that column up because it should equal about 1. If it totals 0.9999, close enough to 1. If it comes up and it comes up to 1.001, close enough. If it comes up to 1.7, yeah, I'm going to call foul on you. But a relative frequency can equal about 1. There's a probability table later in chapter 7 or 6. It has to equal 1, but a relative frequency does not. Has to be about 1, because all the pieces together should equal 1, but when you got rounding, sometimes with relative frequency, we come off just a hair off. But that's our frequency and our relative frequency. The next thing it says to do is do it with StatCrunch. Do you remember how we did it with StatCrunch? Well, over we go. There's our siblings. So, stat tables, frequency. I want siblings. And since I want both frequency and relative frequency, I'm going to show you how you can do both at the same time. I clicked on relative frequency, and for Windows computer, hold down the control button and click the relative frequency. It'll do both at the same time. And compute. There we go. All right. So yes, refresher from 2.1. Now, to construct a histogram. All right. First thing we typically have to do is decide if we want classes or class widths. with this being discrete and not that many, we just go with classes. And how do we draw it? We draw it pretty much the same way. We did before. We have the 0 here. 1, 2, 3, 4, 5, 6, 7. This is the number of siblings. And here is your frequency. And our highest frequency was 8. And there's my 8. All right. Now, when we draw these, you measure from left to right. You read from the left. So 0 has 1. So I'm going to draw it from here to here. So when I look at this, this tells me there is 1 or one student has 0 siblings. Read from the left of the bar. All right. So 2 has, or 1 has 4 siblings. So I'm going to come up to here. Again, remember, bars touch. All right, 3. 2 has 8. I keep looking at the one we haven't done yet. So from 2 to 3, I color in. You seeing the difference between the bar and the histogram? They're all touching. At 3, we have 3. At 4, we have 2. At 5, we have 1. And at 7, we have 1. All right, there's our histogram. Remember again, what's the difference between relative histogram, relative frequency histogram, and histogram? Frequency histogram, as these would be percentages. The shapes and everything look the same. So now it says using StatCrunch. All right, coming over to StatCrunch. Do a histogram, we do graph, and looky right there, histogram. I want to select siblings. I can change it from frequency to relative frequency. Let's put the value above and compute. There you go. As I said, does it look much difference? Let me do the other one. Graph, histogram. This time I'm going to select siblings and leave it as frequency. I always like to put the values above. It's a common practice. but you can literally see the shape and the heights are all the same. It's the values on that left side of y-axis and the values above each bar is what's different. But the one on the left is a frequency histogram. The one on the right is a relative frequency histogram. And looking down, is there much difference between those and a bar graph? So you can see, I understand why students get them confused. The histograms, the bars touch. And here's why. It's because of class widths. First thing you have to do is choose a class, the class width. And how to determine them. Well, to determine a class width, it starts with finding the range. And the range is the largest value of our data minus the smallest value. That's what a range is. And you're going to hear me say this again later on when we talk ranges. But then it's the number of classes that we want. Do we want 2? Do we want 3? Do we want 4? No, it's how many bars do we want? And we divide by that. And then we're allowed to round. So here is an example of a class width. See this? Now, they did do a little bit of a faux pas, because if you look at that, they go 25 to 34, 35 to 44, but then they go 45 to 64. I know it's very hard to read. If I zoom it, it pixelates. That's a little better. But yeah. When we do class widths, we should always keep them even. We shouldn't alter them. They should stay the same widths. Well, if you look at there, 45 to 64, they altered it. And then 65 and older, that typically is okay. And the reason being is because when we're doing ages, a lot of times it's when we're starting to lose our senior citizens. People start to pass away. So we typically lump 65 and older all together. With people living longer, we may have to rethink that. But that really should go 45 to 54 and 54 to 65. Because if you look at that, they make that look like that's really a lot. But is it? We divide that group in two and go 45 to 55, I mean 45 to 54 and 55 to 64, that would split that 63 in half to be around 31.2, 31.5, which actually makes it a little lower than all the rest, doesn't it? So this is things we do in statistics is we tweak those ranges to emphasize something and others persuade you. So watch that when you look at graphs and charts on TVs and such. Did they keep an even class width? If not, why? Oh, it's a big giveaway. They start ordering class widths and not keeping them equal. Now, when is it fair game to have them not equal? One, as I said, like 65 and older. Also, when we're talking adding kids into the mix, because the characteristics of kids, a lot of times we go 0 to 12, and then 13 to 19. Teenage years, kids. We sometimes go 0 to 5, and then 6 to 12. We break them a little funky, but again, it's because if you stop and think about kids, small kids, kids change so much, their characteristics change depending on what we're studying. We do have to break them down based on their characteristics, and it goes with their age, right? Those are fair times when the class widths are not equal. So this is the data set I already have in. And it's unemployment and Canvas. So the first thing we're going to do is construct the infamous histogram, frequency table. And then we're going to just let StatCrunch do the histogram altogether, right? But look at this. It is continuous. So this is when this is going to become important to understand class widths. So I'm going to go over to stat and looky. It's already in there. But remember, to find class widths, I'm going to scroll down here in just a moment. We need this from smallest to largest. So I'm going to click on that arrow down and I'm going to tell it to sort. I'm going to do this again here in a minute. So my smallest piece of data is 2.4. My biggest being 8.4. So remember how we calculated class widths? We take the biggest and subtract off the smallest. And then we divide by the number of classes do we want. So how many classes do we want? Well, personally, I'd cheat. Seeing that 6 being a nice old number, I do 6. So my class width would be 1. Now we do have to calculate this before we go into StatCrunch. So to do this in StatCrunch, I want a histogram. I'm going to go graph, histogram, and this time I'm going to choose rate. There's my frequency, but you notice the arrow down. This is also where I change it to a relative frequency, but I'm going to go frequency. And to start with, that's my smallest piece of data. So I'm going to put 2.4. Remember that calculation we just did of 1. And again, I always like to do that. Boom. Notice how they have the points. Remember I said with a discrete, you write it by the left. Well, with a continuous, we write it one of 2 ways. You read it left to right, but I want to show you something. If I move this and put my cursor on that left side, I want you to look what pops. It's a square bracket, round, in a parenthesis. What it means, it includes 2.4, but it doesn't include 3.4. It's all the data points between 2.4 and almost 3.4. So this is the reason why when we type them up, and I'm being specific on this because of a certain concept check. The square means contains, rounded means does not contain, or almost. And when we're doing this, the very next one should be a square bracket with the same value from the top on the right-hand side. So you're seeing how this would be typed up. Please note, see how that square bracket on the left, rounded on the right? Look when I move the cursor. You see the 2.4 comma 3.4. Technology puts a comma. There again, you see the 3.4 for square bracket, the 4.4 for rounded parenthesis. 4.4 square bracket to 5.4 rounded parenthesis. It's the same thing I have typed here. So yes, that is important. All right. The class widths are calculated from the smallest piece to the largest piece, subtracting the smallest piece of data. That gives us something called a range, and then we decide how many pieces do we divide the range up. I said 6. So that's 1, 2, 3, 4, 5, 6, 7 bars. Why 7? Because I gotta go 8.4 and above. So I could have said, what if I would change that? What if I said the starting point was 2? See any changes? Let me change that back. Let me run it again. By the way, this is another way how we play with this. What did I say? 2.1. Here's one where I tweaked it. See a difference? Look at the first column. That first bar, it went way down, didn't it? And my second bar is about the same, but the third bar? Huh, and how about the fourth? Let's play with it again. And I'm just playing right at the moment to show you guys things that we do. This time I'm going to give a class width of 3/4, 0.75. Oh, looky there. Changed it again. This is another thing we do. We play with the class widths because it can change the shape of our histograms. All right. I can keep playing with that. And feel free to. Okay. So the only difference between the frequency histogram and the relative frequency was the fact I chose frequency versus relative frequency. Let's talk dot plot. Now a dot plot, I do that every time, I'm so used to drawing. A dot plot only has that and it's just as the name says, it's dots, but the dots are stacked. When you read it, you count the number of dots. The dots match the frequency. All right. So going back to the siblings, do you remember how many kids we had under 0? There was 1. So he gets 1 dot. Under 1, we had 4. So guess what? It gets 1, 2, 3, 4 dots. Under 2, we had 8. Frequency of 8. So it gets 8 dots. Under 3, we had 3. Frequency of 3. So it gets 3 dots. 4 had 2. Had a frequency of 2. 5 had 1. And I'm trying to find another color I haven't used yet. 7 had 1. But that is a dot plot. Very simple. You put the number of dots equals the frequency. And across the bottom, you would write number of siblings. Okay? Let's do it in StatCrunch. So to bring this back, I'm going to sort ascend. There we go. Which causes this stuff to kind of like go haywire. But to do a dot plot, it's under graph and looky, dot plot. I'm going to select siblings. And I can change the point size if I want bigger. And I don't want the points to overlap. So compute. There you go. Very simple. One of our easiest graphs. And some students get stumped on. I was like, it really is that simple. It's the number of dots equals the number of frequency, and you just stack them. You just stack them. All right. Let's talk this. Shapes. A uniform frequency looks like this when it gets charted out. What would be one that looks like that? Think of dice. What's the odds of getting a 1 when you roll a die? 1 out of 6. What's the odds of getting a 2? 1 out of 6. Odds of a 3? 1 out of 6. So this is the type of graph that comes from that type of data. It's uniform. It's flatlined. Each bar has the same probability. You'll hear this a little more. That's called uniform. The one on the right, the B, is for bell-shaped. And this is the one we're going to deal with a lot with, these next three, because we want our data to be that. It's not very rarely is it perfect. I've yet to see one in real life that turns out perfect. That's close enough. I make the joke, it's close enough for horseshoes, hand grenades, and statistics. Any of you have ever heard the old saying, it's close enough for horseshoes and hand grenades? It means it's close. I throw in the statistics because very rarely do we get the ideal or perfect. That is close. But you can see, if you draw a bell graph, how it humps in the middle and goes down on either side. It's about symmetrical on either side if I was to draw the bell over it. Sadly, this is more of the stuff that we kind of see. We get skewing. Now, how can you tell which way something is skewed? Is by which way does the tail go? Which side is drug out? So you notice it kind of humps on the left, but we have a long tail going to the right. This is skewed right. This one, the long tail is going to the left, so it is skewed left. Students get this confused by trying to say by where it humps. No, it goes by the tail. We'll get more into that coming up. But it goes by the tail. Caution. We do not describe qualitative data as being skewed left, right, or uniform, only quantitative. All right, and the last example is, let's look at the shape of the unemployment data. So I'm going to go back over to StatCrunch. And even though it's no longer up, you notice there's a 13 above this. If I come down and set results, until I close totally out of StatCrunch, it keeps everything I've done. So histogram for rate. Look at that. If I was to draw a bell over that, would it have a tail? The answer is yes. It would have a tail going to the right. All right. That's it. So this one is skewed right. Well, that is it for 2.3 or 2.2. Good luck.